Our goals for this lesson are understand inverse trigonometric functions and use inverse trigonometric functions to solve problems. First, we have to look back to see how did we find inverses. To find our inverses, remember we switched x and y, which was essentially reflecting the function over the line y equals x. As a consequence, your domain and your range switch. So your domain of f of x becomes the range of its inverse. The range of f of x becomes the domain of its inverse. In order to have an inverse, the function must be 1 to 1. And this becomes an issue with our trig functions. Our basic three trig functions are the sine of x, cosine of x, and tangent of x. You can see that to get a full cycle of each, sine, the period is from 0 to 2 pi. Cosine has a period of 0 to 2 pi. And tangent has a full period between negative pi over 2 and pi over 2. We're looking for something without breaks. So all of these fail the horizontal line test. They'll cross the line several times. So in order to find their inverses, we're going to have to restrict their domains. To restrict their domains, we want the full range of the function. So for sine of x to get from its lowest point to its highest point in a single interval, we're going to look from here to here. So we can restrict our sine function from negative pi over 2 to pi over 2. This now passes the horizontal and vertical line tests. You can see its restricted domain is from negative pi over 2 to pi over 2, and we want to include these endpoints so that we can get to the values of negative 1 and 1. This makes our range negative 1 to 1. So to find its inverse, we have to reflect it over the line y equals x. Okay, so this is what it looks like when it's reflected. Notice the domain and the range will switch. So our x-axis now has the values of the y-axis, and the y-axis now has the values of the x-axis. So our domain is negative 1 to 1, and our range is negative pi over 2 to pi over 2. So note on your unit circle, negative pi over 2 to pi over 2 is this section of the unit circle. So remembering our all students take calculus acronym, all of them are positive here, so you want a positive and negative. Here you can get sine of being positive and sine negative. There's no other two continuous quadrants where you can find that, including this beginning piece. Alright, so now let's try to figure out what exactly does arc sine and inverse sine mean. So essentially you're trying to say what angle has the value of blank. So arc sine of x equals blank. It's saying what angle x has the value of blank. So looking at this first one, arc sine of square root of 2 over 2, we're really saying that the sine of some angle theta equals the square root of 2 over 2. We want to find that angle theta. So we can take a look at our unit circle. And remember, since sine was restricted here on this half of the unit circle from negative pi over 2 to pi over 2, so remember going down is going to give you a negative, we can look for sine, or being a y value, of square root of 2 over 2 is right here at 45 degrees. So our answer is going to be 45 degrees or pi over 4. And we can check, is that in our range? Yes, it's in our range. So we're good and we can keep going. Now, arc sine of negative square root of 2 over 2, we have to find where a y coordinate is negative 2 over 2. Again, I'm going to stay on this half of the circle because that's where sine's range is. So I go over here at negative 2 over 2, and that's 7 pi over 4, or 315 degrees. But now, 7 pi over 4, that wasn't in the range. So since it's not in our range, we're going to have to change it a little. So going 7 pi over 4 means we start here and we go all the way around to here. Well, another way to get to the same angle, being a coterminal angle, is just to go down. And that'll give us a negative 45 degrees, or a negative pi over 4. And there's your answer, negative 45 degrees or negative pi over 4, and that is in fact in our range. Okay, so let's look at what inverse cosine and inverse tangent look like. Again, you're going to restrict cosine and tangent to be a full cycle, and cosine is going to be restricted a little bit differently than sine, being that the graph looks a little different. Here, cosine, to get one full cycle, you can go from here to here, here to here. I just want that full range of values in a section to make it 1 to 1. So we're going to go from 0 to pi. And again, we can include both endpoints. This is going to give us that range of negative 1 to 1. So when we find the inverse, we switch the domain and range, negative 1 to 1, 0 to pi. Okay, and it's going to cross here at the pi over 2. And notice the section of the circle we're looking at is that top half of the circle. Tangent of x, when we restrict it, we wanted one full cycle of tangent, which we can get from negative pi over 2 to pi over 2. So my restricted domain is negative pi over 2 to pi over 2. And notice we can't include these endpoints because those endpoints are asymptotes. They don't actually exist. This gives us a range. You can go down forever, negative infinity to infinity. So then when we find its inverse, the vertical asymptotes become horizontal asymptotes, and our graph reflects over that line. And we're going to get a domain of negative infinity to infinity, which was our range of tangent. Then the range of inverse tangent will be negative pi over 2 to pi over 2, again not including those endpoints because they're asymptotes. So on the circle it looks similar to sine, inverse sine, but we can't include those two endpoints because they are vertical asymptotes. And in tangent inverse, they are horizontal asymptotes. Alright, let's try some examples. Our first example is arc cosine of square root of 3 over 2. So remember, we have a value, we're looking for an angle. So for cosine, we're looking at this top half. We're looking for 3 over 2 being an x value for cosine, and we have it right here at 30 degrees or pi over 6. So I can say arc cosine is 30 degrees or pi over 6. Now your problem will state whether it wants it in degrees or radians. So then I look at our cosine inverse of negative square root of 3 over 2. Again, arc cosine and cosine inverse mean the exact same thing for our purposes. So I want negative square root of 3 over 2. So I'm going to go follow in the top half. X value of negative 3 over 2 is 5 pi over 6 or 150 degrees. And again, 5 pi over 6 is within our range of 0 to pi, so we're good. Now, arctangent is a little bit different. For arctangent, it's saying the tangent of some angle equals the square root of 3. So what we're looking for is our y over x, our sine over cosine, to equal the square root of 3. So I'm going to look for sine over cosine to be the square root of 3. This is going to be square root of 3 over 2 divided by 1/2, because you multiply the by the reciprocal and their 2's will cancel. So this is pi over 3 or 60 degrees. So this is 60 degrees or pi over 3. Okay? So again, this is in our range of the inverse trig function. We're good. Now if I look at tangent inverse of negative square root of 3, I'm looking for the same thing, but one of them has to be negative. So remember, tangent was restricted on this half of the circle. So I'm going to look for one of them to be negative. I want square root of 3 over 2 in my y value, and that gives me 300 degrees or 5 pi over 3. Now 5 pi over 3 is well out of our range, so just like we did for our other problems, we have to go backwards, and this is going to go down negative pi over 3 or negative 60 degrees. And that's because this right here is outside of the range. Okay, so moving on, I have a couple more examples to look at. I have the inverse sine of 1/2. So I'm going to go find 1/2 as my y value, and that's going to give me 30 degrees or pi over 6. Inverse cosine of 0, I'm looking for an x value of 0, which is actually going to be right up here. I don't have it written on my unit circle, but this is the point 0, 1. So I'm going to be at pi over 2, or 90 degrees. Inverse tangent of 1, I need x and y to be equal, so that's going to be right over here at 45 degrees. Square root of 2 over 2 divided by square root of 2 over 2 is going to give me 1. So this is going to be 45 degrees, or pi over 4. This one's a little tricky. It's a step-by-step process. You're going to include PEMDAS, so start inside. The sine of 5 pi over 6. You go around, you find 5 pi over 6. The sine of 5 pi over 6 is going to be your y value of 1/2. So I need to find the inverse sine of 1/2. And we did that earlier. And we have 30 degrees or pi over 6. Okay? Then for my last example is finding equivalent expressions. This is a little bit of algebra with your trig functions. So I'm given the secant of inverse sine of x. So my hint is going to be draw a triangle. So I have a right triangle. Now I have inverse sine of x. So I'm looking for sine of theta inside sine of theta equals x. Well, sine is from SOHCAHTOA, opposite over hypotenuse. So I'm going to have x over 1. So if I put angle theta here, opposite of x over hypotenuse 1. Okay? So now I'm looking for the secant of this. So I have here the secant. We know from our trig identities is 1 over cosine. So for our sides, that's going to be hypotenuse over adjacent, reciprocal of the cosine relationship. So hypotenuse over my adjacent side I don't have yet. So I have to do a little bit of algebra to find it. So let's look at that here. Pythagorean Theorem I can use to find that missing side. So I have x squared plus this missing side I'll call a squared equals 1 squared. Okay, now I'm going to switch to a little bit of pen. Okay, so I want to solve for a. So I can subtract x from each side, so I have 1 minus x squared. I can take the square root of both sides, and I get 1 minus x squared. So my adjacent side is now 1 minus x squared, the square root of it. So I have the square root, my hypotenuse, sorry about that. My hypotenuse is 1, my adjacent side is 1 minus x squared. Now we're going to have to rationalize our denominator. Okay, so I have 1 over the square root of 1 minus x squared. To rationalize, I'm going to multiply by the denominator over the denominator. On the bottom, that's going to leave me with 1 minus x squared. And on top, I'm going to get the square root of 1 minus x squared. And there's your answer. So this means that the secant of inverse sine of x, its equivalent expression, is the square root of 1 minus x squared all over 1 minus x squared. And that is it for this lesson.